Welcome everybody to tonight's presentation, Neuroscience of Dyslexia with Dr. Haft. And I just wanted to say it's sponsored by the Connecticut Science of Reading Group here in Connecticut. We're a newly formed chapter of the National Science of Reading Group. And I'm Lisa Gianni, and one of the admins and founders of the group. And I'm joined tonight also by Allison Quirion, who's a moderator. And I think our other moderator, Sarah, is also joining us tonight. So Sarah, welcome. You can speak up if you want to.
I'm here. Hello.
Hi. And so this is the first and hopefully a series of talks around dyslexia and by Dr. Haft and maybe some other researchers. So I'm going to introduce her and then we'll get started. She is a professor of psychological sciences, mathematics, psychiatry, and neuroscience at the University of Connecticut and of psychiatry at the University of California, San Francisco. She's also the director of UConn's Brain Imaging Research Center and co-founder of the Haskins Global Literacy Hub. She's a neuroscientist who has been conducting research on learning and in particular reading acquisition and dyslexia, as well as on resilience and emotional well-being over the last 18 years. She currently has over $30 million in funding, primarily from NIH, to conduct her research. Fumiko received research training at Harvard, UCLA, Caltech, and Stanford, and has held faculty positions at Stanford, UCSF, and UConn. She has numerous honors, including awards from the IDA, the Learning and Brain Foundation, and the International Mind, Brain, and Education Society, and has published over 160 articles and translation of neuroscience to the public, and has delivered over 250 keynotes. And we are so fortunate to have her tonight share with us this information on dyslexia. So I'm going to let her take it away. Oh, one more thing. Sorry, one more thing.
Please, no.
So before you get started, Fumiko, just for the attendees, if you have questions during the presentation tonight, just post them in the chat because we're going to be recording them and taking note of them. Alice and I will be kind of moderating that, and then we'll spend about 15 minutes at the end of tonight's talk to answer some of those questions. So that's it. Thank you.
Great, thank you very much. And if for whatever reason we don't get to your questions, please do feel free to email me afterwards. And I should have put up an email address, but you can find it on brainlens.org, or if you search for me, you will find it. If you do email me, I would strongly ask to include BrainLens, which is spelled here, or at uconn.edu. And maybe Allison can put it in the chat box, but if you email that one, it won't get lost. If you email me, it could get lost and you might have to email me again. So I just wanted to let you know, but we'd love to hear from you as well afterwards. So thank you very much for having me again. And thank you for being here late in the evening for some. I know I have no idea what time it is in New Zealand, but I saw some people from New Zealand as well. So thank you very much for coming from nearby and also from far away. I'm sorry. All right. So I will get started. So I just want to quickly start by it's a little bit of belated Happy New Year sort of card that we made. And I thought it was very, it went well with our name Haft and then all these H words that we came up with to make sort of a word cloud, and wishing everyone hope, health, and happiness, which seemed appropriate during this post-COVID, still COVID, hopefully we'll be post-COVID within the year of 2021. All right. And as we know, each child is very different. I'm taking two of my children as an example. This is a reason why I have a virtual screen and I'm hiding as close to a closet and giving this talk. One thing that happened during the pandemic is it's really hard to use your kids in your talk, which I used to do a lot more of. And so I have to hide and have them go out play basketball or do something while I'm giving these talks. But this is my older son. He's now 12, but his nickname was Information Seeker from when he was in preschool. And this is him about age 7 or 8 in the subway somewhere. And he's picking up newspapers and articles or magazines like The Economist from the floor and picking up and trying to read everything he can. But on the other hand, he has some other issues such as executive function is not his strength, and he just can't keep his act together. And he is relatively, I don't want to use the word that he's not social emotionally attuned, but he really has a hard time kind of getting cues from other people in terms of emotion for the emotional piece. The other one is Kaito. Now he's age 10, but this is much younger. His nickname in preschool was Story Man. He loved to tell stories. He's very empathic, but he didn't really like reading. But all he had to do, because he was a great storyteller, was to charm his brother into reading a story to him and hop on his back, and he would have the lowest tech assistive technology available to him that would read to him endless without ever worrying about running out of batteries. So very different children, and still very different. He now likes reading, or does reading much more than he did before. But as you can imagine, very different children in very different ways. If you look at one dimension, such as reading, you might see a whole different story or a picture than looking at their social emotional aspects or other aspects all combined together. And this is what we are curious about in our research and trying to understand why each child is so different in many different directions. And now with the focus on reading, as we know, reading is very complex. It's a skill that's unique to humans. I'm sure this dog would love to read this book. It says How to Live with a Cat. But there's been scientific research on higher order primates that have been shown that they can read. This is from a Science article several years ago. But even then, among linguists, there's a strong divide in what people, and a lot of people believe that it's a skill that is very unique to humans. It's an evolutionary new skill that was discovered or developed 6,000 or so years ago with no time for a dedicated brain circuit to have evolved. So we believe that there's no real reading circuit. We are co-opting other circuits. That's important for speech or sound perception, audition, vision, and so on, and object recognition, and integrating those. And we have to train that system to learn how to read. So in many cases, it needs to be explicitly taught. And also it's heavily influenced by culture and writing system. This is the same word, do in English, and then the same word in Italian and in Chinese characters. And you can see that the characteristics are very different. How they operate and map onto the linguistic or language is very different also. And you can imagine that they might be using different kind of networks of the brain. But yet it's highly heritable. If you have a close family member, as I'll talk about in a little bit, about 1 in 2 individuals will develop dyslexia. It varies anywhere from 2 to 3, but it's highly or moderately heritable, and that's what it's known as. And there is a universal neurobiological substrate for reading and dyslexia, which we'll talk about in a little bit in more details. But there's some parts of the brain that's important for phonological processing, other parts for orthographic processing, and it forms a network. And this seems to be universally important, even if you're looking at Chinese readers versus English readers, and also with American dyslexics and Israeli dyslexics, they seem to have kind of similar patterns. This is one study that we did several years ago comparing Spanish, English, Hebrew, and Chinese. And these are very different writing systems, but we see that how audition, speech sounds, and visual print integrates or binds, and how they relate to each other are similar for the 4 different languages, in particular in these parts of the brain. So if I can orient you slowly into the brain, this is the left hemisphere of the brain, and this part is, I'm sorry, you can see, can you see the mouse? Can you see the mouse? Okay, so this is the frontal part of the brain. Is it hard to see? Frontal part of the brain, and then this is the back of the brain, top and bottom. But so this is known as the dorsal system, because dorsal means in Latin. So here's a Latin 101. Dorsal means back, as in your back of your body. And when you think about animals walking in forest, dorsal is the top of the head, aligns with the top of the head. So the top of the head is known as dorsal. And so this dorsal stream is known to be important for phonological processing, broadly speaking, and this network seems to be particularly consistent across different languages. And reading is also complex because we have to think about all these different aspects, anywhere from neurobiological aspects. There's genetic pieces that are important for reading, components of reading. There's no gene for reading, but there are genes that are important for these processes that are important for reading, and brain networks important for reading as well. Also, development is an important piece to consider. You're not going to see too many mothers coming into the clinic with their children age 2 saying that the child is not reading the newspaper yet. And so you have to think about the developmental appropriateness as well. There's also the cultural aspect and the writing system that we talked about already, and then the environmental kind of piece as well. So you're not going to see too many adults who's never gone to school for a day in their life coming in at the age of 60 saying that they might have dyslexia. And the first thing you would consider is that probably they didn't get enough schooling. But in that case, it's black and white, but you can easily imagine that it could get into a gray zone where they go to school, go to school almost every day, they have parents, intact parents at home, but somehow they might be not reading enough at home, or their parents might not be reading to them, for example, and then or they have a lot of trauma going on in the household, and you might start wondering that is not the best environment for them, for example, and those needs to be considered as well. And then there's the social, emotional, and motivational aspects that's important, as you can imagine as a parent and or an educator, how important that aspect is. And so going a little bit deeper into the heritability and kind of how much parents impact their children. So there's this model called the intergenerational multifactorial liability model. I know it's a very long name. It was originally called the multifactorial liability model, which is just this purple box here. So basically what it says is that if you look at the child, there's multiple genetic factors, multiple neural systems, multiple cognitive processes that are important that leads to dyslexia, some comorbidity, or jointly having, for example, ADHD and others. And so you have to think about these multiple factors that are important and may be posing risk to the child. And the added layer here is the intergenerational piece, where the parents have an impact on their child. If you can imagine what kind of impact parents have on their children, it could be genetics that you inherit from the parents, but also it could be the environment. It could be prenatal kind of drinking. The example you might know is the fetal alcohol syndrome. That's an extreme case. It could be substance use and others that could impact the child's cognitive and academic outcome. It could be postnatal income as well. For example, home literacy environment, or having trauma in the home and adversity and so on, but also school and other factors. There's also something called epigenetics, which is a newer kind of field of genetics that's not as static as people once thought. So the DNA, as in genetics, is not, there's no change or in that, but the gene expression is different, and the protein that it produces and the function becomes different, and that could be impacted by the environment. So you can already see that genes and nature and nurture are not dichotomous, and they're not two separate things. There's a strong interaction even at the gene level, but also you can imagine that it's a hot topic in research right now is, for example, I might have risk for dyslexia and dyslexia, so-called dyslexia risk genes. I might not pass it on to my child, but then my child might be a poor reader because I pass on my genes to my child, but for example, it could be something like I have risk for dyslexia, and I don't like reading, so I have no books in the home. I never read by myself. I never read to my children, and then that might create these kind of reading habits, and that creates an environment that impacts the child. So it looks like it's an environmental impact. If you just look at the genes, you might say that there's some just risk genes that might be shared, but I'm not actually the one passing it on to the child. So these are called sort of indirect effects or gene environment correlation. It gets very, very complicated these days. And then there's something called the de novo mutation, which I won't go into, but these are kind of the new mutations that you don't see in the parents, but it's not inherited from the parents. So you might have a risk gene that's abnormal in your child, but your parents don't have it, and it just arose from de novo or a new mutation, and that could happen. I have it as a dotted line here because old parental age, especially dad's age, could contribute to these kind of de novo mutation. So I just have it here, but I'm not going to go into details today. So that was one of the probably hardest parts of this talk. Hopefully the rest is much easier. But to summarize some of these pieces, it's important not just to think about the genetic piece. Well, okay, I need to talk about just one more thing. So, but the important piece here is I don't want people to go home or start tweeting and saying dyslexia can be environmentally produced. That is not the case. Most of the research that talks about genetic is almost 100% kind of explained by genetics, and it's not mediated by the environment at least in what's called the cultural environmental transmission. So it's not the environment that you produce that is going to impact your child, or at least the current research suggests so. So of course, if you drank too much or if you use a lot of substance, it might impact their cognition and academic outcome, but it's not going to develop into a more traditional kind of dyslexia, as we call it. And that is known to be mostly genetically mediated. So there's this genetic piece, but also when you think about reading and not the pure more dyslexia, there could be genetic impact. And what we've shown is that, and other people have shown also, is that phonological processing that we talked about that goes through the back of the brain or the dorsal part of the brain or the top of the brain, this network is important for phonological processing. And this is known to be a little bit more genetically mediated. Again, it's not black or white. And then the other extreme is environmentally mediated, for example, from home literacy and others. People have found that orthographic processing, the ability to kind of code the visual print and then bring it automatically to more of the semantic area and meaning area and link that's in the ventral or the stomach pathway of that's another Latin word. Ventral pathway means stomach. So it's the dorsal back pathway and then the ventral stomach pathway. That's known to be more important for the automatic lexical processing or the visual aspects that leads to semantic, the meaning network, and that might be more amenable to environmental changes. And there's other things that we're going after. It's more research-based, but there's attentional and other mechanisms that are critical. And all of these become a risk factor if you have problems that leads to poor reading. People think that it's in the spell shape curve. As much as all of us wants to be all geniuses or think our children are geniuses here, there's not too many people that falls into this really high end of the spectrum. And most of us, as much as we hate it, we're in the pretty much the normal range here. And then if you're on the other spectrum, then that poses risk to dyslexia or poor reading. And the more of these risk factors that you have, it's thought to be that you're going to more likely be in this tail end. If you have family members, then it's going to give you more liability, or your child more liability, and you'll have a higher chance of developing poor reading or dyslexia. Just as an example, we combine some of these 3 quick measures, such as family history, and then dad's age. I don't want to be blaming dads here, but dad's age, or you marrying at an older spouse. But if you're a mom or if you're a dad here that you got married later and had children later, it's a wonderful thing. There's a lot of advantages from getting married at an older age and giving an optimal environment to your child. But in terms of their sperms and eggs, it could cause more de novo mutation and might have some other impacts and some negative impacts as well. Very small impact. And then there's this environmental impacts. If you measure home literacy and family history, as well as father's age, at least in our small sample that we had, we were able to predict 50% of the variance of child's reading ability at grade 3. And of course, a lot more research needs to be done, but we're trying to gather a lot of these risk factors so that we can make a more informed risk calculation of the child's reading outcome. And as we know, there's a lot of negative consequences of dyslexia. For example, as I said already, if you have a close family member, about in 1 in 2 or 1 in 3 cases, you will have an offspring or a child with dyslexia, and it's thought to be 4 to 8 times higher than the general population. The cost of the individual is high. For example, this is a statistics from the UK government and foundation. Cost of the society is high as well. High school dropout rate is thought to be higher, and this is just probability. So it's not that it's just probability, and it's not that all children are going to have struggle, but it's more likely than the general population. Prison population is thought to be higher, except for the research is quite poor and old in this area, and a lot more new research needs to be done. The way they identify dyslexia or learning disabilities wrong to start with, they use IQ measures, which is not the way to identify learning differences or disorders, as we know. Anxiety is thought to be higher, especially test anxiety, 5 times higher than the general population. Depression is higher, and then substance abuse higher, and ADHD is thought to be higher, especially the attention deficit subtype. So it has a lot of negative consequences of dyslexia. There's a lot of value in early identification and preventive intervention in these children. And despite a lot of the efforts that are going on nationally for the many past decades, 1/3 of all children still read below basic level. 2/3 of all children read below the level of proficiency and proficient level of reading. And the sad part is that there has been no change despite all these efforts in reading level for almost decades, according to some statistics. And if you look at adults, over 1/3 of all adults cannot read drug labels, with low literacy costing the United States economy $230 billion a year in healthcare costs. So we believe that all children have the right to the best learning experiences, and we must arm the teachers with the knowledge and skills to maximize their potential. So more on neuroscience, since this is the topic of the talk today. But I want to talk about the simple view of reading, and you may have heard and seen this before. This is the reading rope, and it's a very simple model, but there's a lot of kind of great things to it and depth to it as well. But the simplistic view is that oral reading or oral language comprehension is important for reading, skills reading, and also word recognition is important. And these are the basics for becoming a skilled reader. If you don't have one or the other, or not strong in one or the other, or struggle in one or the other, you could become a poor reader and struggle in reading. In terms of dyslexia, it's crossed out here in orange, but this word recognition piece is thought to be they are thought to have struggles in word recognition skills in particular. And this has gained a lot of momentum, especially in the reading instructions, reading interventions, educators in those areas and fields, because it seems to have great basis and impact on the instructions that we provide. If you look at brain imaging, it does have a parallel as well, and it maps on really nicely. So we've been talking about the back pathway or the dorsal pathway that includes this TP or temporoparietal region is a core region thought to be important for phonological processing, but it's a network. And then there's this orthographic, the lexical kind of semantic automatic pathway that's in the ventral or the stomach part pathway, which is known and centering around the occipital temporal region. And these two parts are particularly thought to be, these temporoparietal and occipital temporal region is thought to be particularly weak in individuals with dyslexia, which is the one that's directly involving this back pathway or the dorsal pathway. It also maps on nicely the computational model of reading, in particular the triangle model. I'm not closing the triangle model here just to make a parallel here, but there's this dorsal, again, the back, the orthographic to phonological pathway, which is this pathway here. And then there's this ventral or the stomach pathway that maps on from the orthography to the semantic pathway. And this is thought to be relatively intact in individuals with dyslexia, or maybe even a strength in some. And I talked about some of these. We'll talk more about the strengths of dyslexia. But so one idea is potentially to really kind of strengthen. You have to do both because it's a rope, as you can see here. You can't just train and make the green part stronger, and it's not going to completely compensate for the orange part. So you do need to just work on both. But it could be one pathway where you can get the readers to be stronger, dyslexic readers to be stronger, and potentially that would allow them to compensate for their skills. And we'll talk more about this later. In various research, we've shown that these two parts, the temporoparietal, occipital temporal regions, are dysfunctional or reduced in kind of efficiency in individuals with dyslexia. And we've shown that they will not grow out of it. This doesn't mean that intervention is not important. We're just saying that waiting is not the solution here. Some people have said that there's a maturational delay, wait, and they'll grow out of it. They're a boy, so it's going to be fine. And that is not the solution. And that's what we've shown in multiple imaging studies. We've also shown that it doesn't matter what definition you use to some extent, that even, so whether we use the older kind of definitional model of discrepancy model or low achievement model, I won't go into the details, but I'm happy to talk about it later. Regardless of what you use, we see these patterns in individuals with dyslexia. Also, the interesting thing is if you take a good reader based on a standardized reading measure, but if they're very high in cognitive abilities or IQ or general kind of cognition, some people say that there's still a discrepancy. So these individuals, even though their reading might look normal, but they have a dyslexia-like trait and they should receive accommodations, for example, or interventions or services. And so half the people say no, they don't, because their reading is absolutely normal according to these standardized measures. And so what we did was we looked at those individuals. They still show some patterns of dysfunction in these regions, suggesting that these good readers that have super cognitive abilities still show these dyslexia-like patterns, and they might have dyslexia, but they're just kind of being masked because of their other cognitive skills. Also, we've shown that it's a neurobiological in origin and not cultural, or depending on the writing system. We looked at Chinese dyslexia, English dyslexia, and so on. They show similar patterns at its core. And then also the white matter pathway that connects between this. This is the back pathway that we've been talking about. In particular, this pathway seems to be important and predictive of reading acquisition. So all of this is pointing to these two core systems that are important for reading and dyslexia. But we also need to note that there's a large individual variability. That, as you can, if you're in the classroom, you can take two children who might have dyslexia, but they might show fairly different patterns, and that's what you're going to see in the brain as well. But as a group, we see these patterns. If you take children who are not reading, so one group could be high risk, meaning that they have a family member with dyslexia, but they're not reading. And we looked at those individuals to see if their brain patterns are different than those with low risk, so who don't have a family member with dyslexia. And you can already see that these bowls, meaning that their network patterns are quite different, much smaller in individuals with high risk. And so if we can identify this in the brain and see these kind of atypicalities or differences already, this also means that we really don't want to be waiting and failing our children. It must be something that we can do much earlier on. This is just a combination of all the studies that have been done, including from groups from Europe, as well as Nadine Gabb's group. And we show that we all show conversions that in pre-readers, we can identify biological signatures already. So we don't want to wait to fail our children. So we've been going through this dyslexia network, so I won't repeat this, but I just want to point out that there's a lot of networks that are important in reading. We talked about this stomach pathway, the ventral pathway, the lexical, automatic, kind of semantic pathway, but there's others as well. There's the syntactic pathway, there's vocabulary related regions, and also general cognitive functions such as attention, which runs towards the back of your brain to the top, executive function often in the front, but also connects to the other parts of the brain, frontal parietal network, some people call it. But these executive function and attention networks are also critical as well for reading. Of course, if you only have those, you won't be able to read, but it makes you a much better reader, which also shows promise that potentially if you are weak in other kind of phonological network, as in dyslexia, for example, that we might be able to strengthen others to support the weaker system. Again, I don't want to replace the traditional evidence-based effective interventions, but there could be room to promote other aspects as well. So this is just to show that, let's see, This is not particularly important. I think I made the point already that other parts of the networks are important. This is just showing that these attention learning networks are also coupled with the phonological region. So and shows less kind of coupling in individuals with dyslexia, meaning that they're not integrated well in the brain. And there's other kinds of subtypes, and we're seeing very subtype specific network patterns, for example, and they have an additional rapid naming or processing kind of problems, and they might have more severe reading problems, and we need to attend to those individuals as well. I think we want to it's very curious because if you look at interventions and look at the brain, what parts of the brains are important for interventions, you might notice that you don't see too much going on here. This is the phonological and the orthographic network that we've been talking about, and we don't see any changes or core regions here for interventions. And what we see here is these other parts of the brain that seems to be important, at least empirically using research, seems to not only be important for language and kind of reading, but also for cognitive function and other kind of non-reading related language functions. And I'm going to talk about more of these parts here. So you don't have to pay attention except for to say that, interestingly, intervention doesn't seem to normalize the brain as some people might suggest, but it might be that it's potentially kind of acting on compensatory networks. Of course, we don't really know that these brain research is often inadequate in terms of how much intervention we provide. So it might be that first, when you're learning to read and receiving interventions, you might use your compensatory parts of the brain, and then your real kind of these yellow regions, phonological and orthographic, might be kicking in later, and we might not be picking that up. But in any case, it's curious to see that there's a lot of these compensatory circuits that are starting to show up. I'm going to skip this one because it's just making the point that other parts of the brain, it's just kind of individual research studies that we've shown that are showing the importance of compensation, except for to say that potentially the articulatory network seems to be particularly important. It's curious. It's very curious because I know young children, we know that young children, when they learn to read, articulation is an effective strategy. And it's nice, what we're showing here is that dyslexic individuals might be using that articulatory network and really trying to compensate. And typically when you become an adult, you don't have to use those strategies. So most adults won't use their articulatory kind of articulation, but it seems like dyslexic individuals might be continuing to use that as a way to compensate. So to summarize this section, phonological and orthographic processing is important in reading and dyslexia, even in pre-readers before they read, and is impacted more by the genetic heritability that you get passed on from your parents. And and it also shows that there's no reason to wait to fail our children. And then it seems to be the case that there's some parts of the networks that are more impacted by nurture or environment, such as the kind of the orthographic and semantic pathway. There's other processes that are important, such as cognition, attention, processing speed, articulation, and these might be a way to tap into the compensatory network. So we're going to focus a little bit on the other pathways that are important. It's going to be much shorter in this part. So I can't read my slide here. Let me see. So I want to talk about how we can conceptualize these protective factors, compensatory factors that might suggest important factors to consider in dyslexia and their outcome. So we see this as an umbrella term, protective factors as an umbrella term, and then there's these resilience piece and compensation piece. And this is what we've been finding in research, the different factors that are important. So resilience, as we see it, and often we think about the social emotional resilience. So you live in adversity, poverty, and you have a lot of violence going on in the home, but you might end up being very kind of happy and successful. And we might call those children resilient children. But we're applying this to not just the social emotional aspects, but the cognitive aspects. So we define this as a positive outcome, then what's expected given its biological vulnerability. So in this case, it might be having the genetic risk or biological risk for having dyslexia, And you might, even though you have those biological risks, you might end up being very successful in reading and do quite well. And these we call resilient readers, and it could be coming from some of these social emotional aspects as well as cognitive aspects. Compensation is defined as the alternative mechanisms to reverse the deficits or the problems. So in this case, it might be decoding problems. And compensation might be you're not using the typical back of the body pathway, the dorsal pathway, or the phonological pathway to learn to compensate or to learn to read if you have dyslexia. You might be using the more of the stomach pathway or other pathways that allows you to compensate. And we think that there's language pieces that are important and some non-language kind of cognitive pieces that are important. So this is what the behavioral research has shown over the past. So you can see that semantic knowledge seems to be very important for compensation. We're going to focus on the compensation piece first, but semantic knowledge seems to be important, lexical context, but I don't want you to start saying that we want you to start guessing the context. That's just quite different, but some kind of having a background knowledge is very important, is what we're trying to get at, and that would facilitate their reading abilities. Morphological awareness. Morphological awareness is the smallest unit of meaning in a word, and these are thought to be important for developing compensatory skills. Receptive language skills, meaning that if they can hear and comprehend well, that means that their oral language skills or receptive language skills, if they have strong receptive vocabulary, and vocabulary is a great skill to have, and that might help them compensate as well. And then we talked a little bit about articulatory strategies. And then there's something unknown, which is coming more from the brain literature, that shows that maybe the right hemisphere might be important, even though the language and the dyslexia circuits are often kind of represented on the left hemisphere. And people have seen this multiple times. We don't quite know the function of it yet. And of course, what we think is going on usually with the intervention is to reverse their weakness in phonological and grapheme phoneme conversion. But as I showed you in the brain imaging studies, it might not just be reversing, and we might not be capturing that in brain science research studies, but seeing more of these compensatory mechanisms. We will also want to think about the resilience framework that we talked about already, which is basically you have risks, but they might not develop dyslexia or might end up having very not severe dyslexia. And we found that these factors are important in terms of cognitive and language skills, such as morphological awareness, so they overlap executive function, and you've seen a lot of these already, oral language skills and so on. There's also social emotional factors that are important for resilience as well. And these are things that you can, I will be sharing you with a slide so you don't have to take notes here, but there's some child-centric factors, family-centric factors, as well as peer and school-related factors that we have identified from previous research done by a lot of other people. I'm happy to go into the details, but I can talk for an hour about just that piece. So I'm going to skip through and move on. This is an example of the cognitive resilience piece, but basically we looked at resilient readers, which are defined as good comprehension despite poor decoders. So you might struggle to read each word, but when you ask comprehension questions later, they will answer quite well. These are individuals who could also be a problem because a lot of the school-based reading assessment could be comprehension focused, just to keep it very simple and quick. And then they might get missed and fall between the cracks, and they might have problems later on also. But we looked at these children and compare them to two different groups. And what we're looking for is this resilience factor. Who are the individuals that have this gap between poor decoding and good comprehension? And what we're finding is that this prefrontal executive part of the brain, cognitive part of the brain is quite important in these resilient readers. And this region also predicted in pre-readers who is going to later develop resilience. So this suggests that perhaps these executive skills are very important, and that could be tapped into to promote resilience in these children. And this region in particular was related to learning, memory, and cognitive flexibility. I'm going to skip this part, but I have this because I thought some people might be interested and ask questions. So this is meant for a Q&A, but this is kind of deviating into the intervention piece. But I'm happy to answer kind of recent updates and executive function interventions. But I'm going to skip this for now, and please do ask. But what we do want to show is that we have a summer camp opportunity for those in Connecticut or can be here. It's an in-person camp following the strict guidelines of COVID guidelines from the university as well as local health authorities. It's a 5-week free camp, including lunch, all arts and other activities, snacks, and it will be done on the STORES campus. We will likely provide transportations from places like Hartford as well. We're looking into early care and aftercare as well. And we'll be providing a lot of different kinds of interventions. You don't get to choose, unfortunately, because this is part of research and supported by research, but anything you get will be a plus. It could be math, it could be phonics, the grand kind of reading intervention that has been shown to be effective, evidence-based. We might add on a morphology piece, we might add on an executive piece, you might get math interventions, and then we have a brain piece so that the kids can learn about the brain, and we get some brain data in real time as they're doing interventions to track their brains, and also doing a number of psychological assessments to see how the children's motivation, reading level, math levels are changing. So if you're interested in this, please do contact us or check out on our website, and we'd love to have you as part of this summer. They turn into the social emotional piece, which we don't have in the brain camp right now. We'll be measuring it, but we won't be doing interventions targeting this. But we know that students with LD experience struggles in social emotional aspects. We talked about this in the original earlier slides already, but we showed here in a relatively large sample that individuals with LD learning differences or learning disabilities, not just dyslexia or not just with ADHD, but they have more, all combined have more anxiety, they have higher depression, and also they have a lower sense of mastery. They don't feel like they've mastered particular academic subjects. And then they have a lower growth mindset, meaning that they feel like their intelligence is fixed, and even with effort, they can't change. And so this is the characteristics that we've been seeing in children. This is primarily middle school children with LD. And so we did a mentoring based program to see how that might change. There's a lot of different ways to change and promote resilience, but one thing we did was a controlled trial or a research looking at mentoring. And what we found was it promoted resilience. This was an art-based near mentoring program in the United States. I'm happy to explain this a lot more, but their depressive symptoms went down, self-esteem went up, interpersonal relationships got better, and growth mindset got stronger as well. And I'm not going to explain this graph, but I just have it to point to it if people had questions again later on. But basically, they were protected from worsening of depression. That happens in a lot of their LD peers if they didn't get mentoring. And in fact, it improved. It wasn't just protecting them. And there was a drop. It protected them from a drop in self-esteem. And in fact, it increased as well. And in their peers, their interpersonal relationship got worse, but then in their case, it prevented them from getting worse. So there's a lot of positive benefits from peer mentoring. So getting to the end, how is my storyteller who struggled in reading growing up and received early interventions 3 years later? This is me giving a talk. Now it's almost 2 years old. I was giving a talk at a baseball Oracle Park in San Francisco at an event. And then I sometimes bring my children. I brought him along that time, and he hates writing. He still does, but he said he wanted to take notes and he wanted a piece of paper and pencil. And so I thought, wow, this is fantastic. Any occasion that he wants to write is great. And he said he was going to give me feedback. And so I thought it was fantastic. And this is what he wrote and gave me at the end. He said, I droned too much. I was too quiet. I said, I'm too much. I didn't use hand gestures, and I sounded bored with only a hint of enthusiasm. So there you go for motivation. If they're motivated, they would write, and they would write extensively. And I was very happy, and I'm still happy to this day that he did. He was motivated enough to give me feedback and write these notes. So to end, can we help our children succeed? I think with our, yes, we can with our joint efforts. So thank you very much. And I'm happy to take questions. I think we have 15 minutes left.
Thank you so much. That was great. We do have some questions. So starting from we have some questions around research. What measures are best to detect these brain patterns in pre-readers?
What methods are most
Measures.
effective or
Measures.
most measures? So is it behavioral measures? Is that the question?
Elena?
Yep, sure. I was asking specifically about what measures we could use in schools to kind of measure those pre-readers, right? So kids who are coming into kindergarten and aren't necessarily reading yet, are there ways that we can kind of identify
Yes.
like a lowest, let's say 20%? And right now we're using something called the Arkansas rapid naming color screen for that, but I wondered if there was anything else available or any other measure that would help target a specific group before they're actually reading so that we could support them before.
Yes,
Yeah.
absolutely. So one way is the quickest way, and it's, of course, there's no free lunch. So the quickest way is not the most accurate way, but there's benefit for quick early screeners as a first pass. What we're trying to promote as the Connecticut Task Force for revising the dyslexia law that Allison has been central in is, for example, adding on a family screening measure, family history measure. It's used to be extensive. It's a 15-minute sort of a screener. We've devised it so it's only 6 questions, and we're kind of almost about to get it published, but we have it up on our website or up online somewhere, and I'm happy to point to you to those 6 questions. I have a quick write-up of it that you can use as well. So something like that could be done as a universal first pass when they enter school, for example, to get a sense that at least if they have family history, they're more at risk. The other measures are, for example, phonological awareness measures. Oral language is an important measure. Vocabulary is good to measure. But, and I'm going down sort of in the order of importance here. So phonological awareness, letter knowledge, letter sound knowledge are important. And then you can measure oral language, for example. So it gets longer and longer, but those are some of the most important kind of measures that you can, and there's a lot of assessments that are out there.
Great. Thank you so much, Dr. Haft.
Thank you.
Thank you. And another question around research. Monica wanted to know if there was any research projects recruiting patients for a study of compensatory methods.
Yes, so it depends on the population. And of course, research, we can't just give it to, we can't enroll anyone because we're funded by everyone's taxpayers' money. Thank you very much. And so we can't just deviate and say, oh, I have a friend, or it's your good friend, so I really want to enroll and help. But in our current study, there's one for young adults, 18 to 30 or so years of age. And it's for a lot of kids or young adults. If they struggled in reading, but they're decently good readers now, but they're curious, they can participate. If they continue to struggle, they can participate. If they've always been a good reader and if they're friends and they want to support and join, they can participate as well. And that's particularly focused on looking at compensatory mechanisms using the latest and greatest neuroimaging technology.
Excellent. Thank you. And then we had several questions around diagnosis. So if you could just kind of speak generally, but I'll tell you some of the talking points. A few of the attendees wanted to know if when you're speaking about dyslexia, you're speaking about the whole umbrella, including dysgraphia, dyscalculia, and or are you just talking about reading alone by itself? And then another.
That's a question, I'm sorry.
That was a question, yes. And then a couple other people wanted to know about twice exceptional kids.
Great. So when I say dyslexia, of course, they do have word decoding problems is often what I'm referring to. And when I say LD, learning differences, it's broadly, usually a lot of our research at least has used it as an umbrella term. such that some people might use the word learning differences, and includes dyslexia, but also ADHD and other kinds of learning differences. Of course, even when we do dyslexia research, we have a lot of people who have writing dysgraphia, dyscalculia, and others as well, because if you start just looking for the pure dyslexia, I almost want to say when I look at neuropsychological assessments and talk with family members, if I see a more pure dyslexia that only has decoding problems and phonological awareness problems, I almost want to say congratulations to those families, because we know that evidence-based interventions out there, we know what works, and it's a very clean case, and they're more likely to respond instead of those who have multiple kind of learning differences or learning disorders. So, but having a comorbid case or multiple kinds of learning disabilities is more of a norm. If you look at it, it's usually 30 to 60% or 30 to 40% overlap in with these other conditions like dysgraphia, dyscalculia, and so on. So I'm including all those, but at its core, they have dyslexia, decoding problems.
Okay.
And then twice exceptional. Is there a particular question about twice exceptional children?
The question was, they would love to hear about twice exceptional kids, what the best approach to diagnosis is, and seeking out the best intervention services, because schools don't typically recognize those kiddos.
Right, they don't recognize it, and a lot of neuropsychologists or outside providers don't like they love those kids, but it's just really difficult cases, and also a difficult case to make with the schools, and because often they're coming to outside services because the school doesn't recognize it, so it makes it really challenging, and kind of the psychologists often shy away from identifying. There are certain people who specialize those, and I don't know. It really depends on your location, but now a lot of people might be doing remote assessments, so it might be a good time, especially with COVID. But it seems to be a more specialized kind of psychologist that you need to go to, unfortunately, because they have to really pay attention to the error patterns and others to really make the case that it's not just that they have strength and they have some small weakness in something else, and that often gets dismissed. There's good resources on various sites, but I think one website that could be good is understood.org. They have a number of different resources related to this. But if you have specific questions, I'm happy to answer. It's hard to kind of talk about it, especially because the audience is coming from such a broad area.
Amber, Aaron, did you want us to add on to that question? No. Okay.
Yeah, I'll
Oh,
just
go
say
ahead.
that yeah, my son is 7. He has ADHD. That was the first thing we diagnosed. He's in 2nd grade, and I've just found where I've mentioned dyslexia from the get-go, and it's just kind of he flies under the radar and really masks the dyslexia. And I've researched the stealth dyslexia term, and I feel like that's kind of what we're dealing with. So it's just trying to find folks to understand that, and how do you get the services that you need without the discrepancy model.
Right. Yes, the stealth dyslexia. So we call them resilient dyslexia, and we talked about that a little bit in my slides here. That is really the hard one, because they could get unrecognized because they might be decently good at reading comprehension, or in this case of resilient readers, it's really hard. I think we really need to identify, document someone who could really look at the error patterns and would advocate for you or your child, because if you look into kind of speeded measures, for example, they might show up. If you look into more kind of under stressful conditions, they might show up a little more. And so it's really needs someone who wants to take that on. Where are you from? Which state? Or Amber?
We're in North Carolina.
North Carolina. I don't particularly know anyone there, but if you can look up some of the understood.org kind of, there's also a great newsletter that I like and I subscribe to called 2E Newsletter. I think they made it free. They used to charge $5 or so per year or $10 per year. And it was very, very minimal in terms of the cost, but they have a newsletter. And if you contact me, I can dig out an old newsletter and I can send some to you. And if you like them, you can subscribe to that. It seems to have decent kind of scientific, good content, but accessible. And so that and Understood are good resources.
Thank you very much. Moving on to intervention. We had like several questions around intervention. So I'll read a couple of them. Could we talk more about other ways to support individuals with dyslexia? That is not the typical information. That is not the typical intervention recommended. What other functions can be strengthened and how?
Yes. So since we talked about executive function, I'll just show the slide. That was a very busy slide that I skipped. And then I'll just quickly stop because I think Lisa or this Connecticut Science of Reading group might be organizing separate sessions in the future.
Yeah,
just
sure.
focus on interventions, how to look for interventions. So I'm not going to go into details, but I just want to show this one slide. So what I want to say is that these computerized executive function training has not been shown to be, is very, very controversial. Some people show some effects. In most of the cases, it's very negative. So I would not jump on to executive function training apps that says brain train programs and so on. But I would recommend that there's one FDA approved. For the first time, this is the first game that has been approved by the FDA. That's not medication or other kinds of medical treatment to support ADHD. And I don't have the slide up here right now. Shoot. It's a company called Akili. It's a spinoff from UCSF, and that's why I follow them really closely. It's to improve on attention, and it's a gamified version. You can go to your doctor's office and get a prescription, or you can join any of the trials if there's any trials going on. I would look up a site called Akili, AKILI, and you can find more information about that program. And I know the people who developed it, and they're very solid researchers and neuroscientists. Other kinds of training that has been shown, this is just really just reading every single paper on these in executive function, but people have shown that reading strategies intervention to whole classroom can be beneficial, especially in upper grades, and it has shown to have long-term effects. And in particular, setting reading goals, which taps into sort of meshing executive function and reading, seems to have a positive impact. So if you just do a training computerized program, it might not work, but if you mesh it into your reading intervention program, it might have a particularly strong effects, such as setting reading goals and so on. And this is a combination of 52 studies, so I think it's quite strong. There's other groups, for example, that are talking about saying that the most successful approaches for improving executive function will also address emotional, social, and physical needs. And what people have found in a study that combined 90 studies fairly recently have shown that acquiring new strategies for self-regulation. They write in biofeedback. I don't want to be putting biofeedback in the front line and saying everyone should go and hire a biofeedback intervention person because it's often expensive, and not all biofeedback practitioners are doing kind of a rigorous approach that's based on science. But in these research studies, BFL have shown that biofeedback enhanced relaxation and strategies teaching program seems to work. So it seems like it's set around strategies and setting goals, seems to be the most effective so far around executive function. For non-LD students, it seems like mindfulness practices had an effect. Computerized and non-computerized training related to executive function had some effects also, but I don't think enough work has been done in the LD dyslexia population. So we need to do more research. It doesn't mean that mindfulness doesn't work. It just shows that in typically non-LD dyslexic, non-dyslexic kids, it has shown to be useful. We're after this. We got a huge US nationwide network grant from the NIH recently, just really focus on mind-body interventions and emotional well-being. So we'll be doing a lot of research in this area over the next 4 years. And I'll stop there.
Okay. Do you have a little bit more time to do some more questions?
I'm happy to stay on. I know a lot of people must need to leave. I'm happy to stay on for another 15 or whatever minutes.
Okay, perfect. We have some questions from the beginning of the slideshow of the presentation. Help me understand, are you saying that the amount of books will help not have children who develop dyslexia? I would argue this point if I read 5,000 hours to my child and have thousands of books in our home and my child still has dyslexia.
Yes, no, absolutely. You are right. I'm sorry. This is the one where I was kind of commenting on saying, I don't want people to go off and tweet saying that environment and home literacy environment can create dyslexia, because it doesn't. The point that I wanted to make there was dyslexia seems to be largely genetically driven. So there's some biological basis to it. We don't know exactly how it works, but we do know that it's not because the parents don't have books at home or the parents have not read enough at home, and it's not the parents to blame. And that is the main takeaway point. So it's almost the opposite of what you're saying. So I apologize that it was very confusing.
No, thank you. And then we have a question on mentoring. Are there any mentoring programs like that in Connecticut at this time, especially Eastern Connecticut? I'm curious as to what mentoring program was used in the study.
So the mentoring program we used was called Eye to Eye. It's a national one specifically focused on LD, including dyslexia and ADHD. You can look up their website to see if there's a local one near your school. You can, if there's sufficient interest, I think you can talk to them and they can tell you how to set things up at your site. Usually they find a middle school group of students, schools that they want them to sign up, and then they would pair them with high school or college age students that would be doing the mentoring. And often it's done at school on a 1-to-1 or 1-to-2 basis. So check out Eye to Eye, which is their website. There are some other, I'm not sure if I saw a comment. I see a lot of comments here, so I apologize. I'm not checking the chat box, but there are some other mentoring organizations as well. Super Squad Dyslexia, for example. I know the people in Connecticut who's doing that. They do it remotely as well, and 1-to-1. I don't really know the science behind it. I don't think a lot of the mentoring program, I think this is the first kind of LD mentoring program that has been brave enough to ask an external party like us to do their research, knowing that if we couldn't find anything, that they're at great risk, but they took the risk and we did their research and it worked out well. So not others have been validated to the extent that ours have, or the Eye to Eye has, but there are other programs like Super Squad Dyslexia, I think is the one. If you can look them up or you can contact me. It's the proper name is, I can't remember the proper name right now, but I think that's what it is. So there are others, but Eye to Eye is the one that we worked on.
Okay. Thank you. Another question. Are there okay, that's more for us, follow-up webinars. Can you explain what it means when a compensatory effect is realized and at an adult age, dyslexia appears non-existent, and what studies are doing with young adults?
So I'm trying to think of what the question is. I apologize if I'm
Heike, if you want to speak more to that question, I think, Crowland.
Sure. Hi. Yes, thank you. It's Heike.
Oh, Heike.
So essentially, it's okay. Everyone calls me Heike, so I'm so okay with that. So the question essentially has to do with everything that you were talking about is that the dyslexia never goes away, and essentially all the brain diagrams that you showed kind of show that the patterns exist there, and so that you were saying that the brain compensates in other ways. If children are severely dyslexic and dysgraphic and really fall under most of those categories in the umbrella, by the time they reach adulthood and it's almost non-existent where you don't see it, how is the brain actually compensating all of that, and why does the imaging not really show that anymore? Like, I guess I understand that the brain does something, but what is it doing exactly to really take that completely and turn it around?
So I think it's an active area of research. So the bottom line is it's an active area of research. I think we're the first group that has been funded to do compensatory, to look at compensation in individuals with dyslexia from NIH, a large scale study. So we don't know is the bottom line. We suspect that these, they're co-opting the cognitive executive function networks, cognitive flexibility, and for example, language networks and others to compensate. But is that what you're not asking? I'm sorry.
It's kind of what I'm asking. I guess I'm trying to understand how
Happens?
yeah, I'm trying to understand the extent of that compensation. You know, to really be at a point, because I know that several areas, like you talked about, like the verbal aspect and all of that, and you know, verbal was actually one of the skills that was through the roof. You know, but the dysgraphia portion of the dyslexia was really one of the weakest ones, and so I'm trying to figure out what kind of compensation occurs to make that completely turn around.
Right. So yes, again, I will just say that we don't know. We think we have a brain-based hypothesis that there might be some neuroplasticity or this rubber band like that's plastic, so neuroplasticity in the brain that's more amenable to certain changes. And we think that there's some individual, it differs by individual. We're trying to kind of tap into different ways to figure out why some people might compensate using certain strategies and why some people might use other strategies to learn to compensate, and whether there's that much of a difference. And I'm sorry to say, but we're just kind of doing research. We're right in the middle of it. So maybe in a couple of years, we'll have something great to say. But the extent that I showed you is pretty much all the research that has been done on compensation. So it doesn't really get at why and how, sort of, in a way.
Okay, well, I'll follow you for a few years.
Yes, please. Sorry.
No. When you're doing most of the research, are you doing it on the comorbidities? Are you doing it primarily with more the truer form of the when people hear dyslexia, they think the reading component of it? I was that original question with the dysgraphia and dyscalculia. Are you including all of that? Or?
We are including, so we don't exclude based on dysgraphia, or we don't exclude based on dyscalculia. And we take a lot of different spectrum of young adults. So we take most comers.
Great, thank you.
And thank you. One other question we have is, Marilyn is interested to know if there's research regarding the connections between language and math, especially oral language, language retrieval, and language organization, because students with these difficulties may experience problems with the internal monologue that supports math reasoning and sequential operations.
So I think there's a lot of some core similarities between math reasoning and, for example, reading comprehension skills. So then that would be things like oral comprehension, and executive function might be some of them also. So I think there's a lot of commonalities between those. Some, and especially around oral language. I think some researchers hypothesize that phonological awareness is important for some of the math computations, or some of these particularly related to route memory. And I hate to use the word route memory, but some of these more simple operations like 1 + 1 = 2, 2 × 2 = 4, that becomes more automatic for kids after a while. Those might be shared between reading from phonological awareness. So different kinds of language and reading abilities seems to be shared for different components of math, if that makes sense.
Okay, we're gonna get.
Thank you.
Thank you. We're getting close to that 15-minute mark. So I have one final question, then we'll kind of wrap up. We have a guest who would like you to speak a little bit about the strengths dyslexics have.
Strength. So strength is, it depends on how you call what you determine as a strength. So some people might call relative strength among their weaknesses as strength. So I might be really weak on decoding, but I might be good at visual spatial and building things, for example, or I might be good at math, for example. And but I might not be an Einstein mathematician, but you might call that relative strength. Some people will define relative or strengths as those who are even better than most other people. And that's a little bit harder to find, except for we've done research. There's several other research out there. It's a little tricky measure to measure, but we have shown, for example, that visual spatial abilities and reading shows a yin yang relationship. So some people might say, oh, there's a lot of architects and kind of more spatial thinkers and individuals with dyslexia. I'm not sure if there's 100% truth to it, but in general, we've seen this relationship where if you're a poor reader, they tended to have better visual spatial kind of abilities. And this was purely measured based on this impossible Escher-like figure. And we have to have them, we asked the individuals to say whether it's an impossible or possible figure, like those staircases that never ends, for example. And then they were quicker at responding to that if they were poor in reading abilities. And there seems to be brain signature that corresponded to this. We published this 5 or 6 years ago. There's several other behavioral studies that show the visual spatial strengths. I think that's where the most evidence is. There's not quite enough for others. Of course, it's often that it hasn't been done more than it has, it's not there. Also, just technically, I have to say that it gets a little bit technical, but if you define dyslexia based on reading difficulties, it's really hard to find a consistent pattern in anything else that you measured. Of course, if you find kids based on their high IQ measure, it's easy to find high IQ kids, but it's going to be hard to find low reading ability kids just because everything else is not controlled for, so it's everywhere on the map. So it's really hard to find these effects improve, but it seems like there might be some truth in kind of this yin-yang relationship, at least in spatial abilities.
Great. Thank you. Fumiko, would you mind putting up the very first slide of the slideshow, the intro slide?
Yes, absolutely.
Thank you. And so just to wrap up this evening's presentation, if we didn't get to your questions, Fumiko, did you want people to email you at BrainLens or?
Let me just put
yeah, do you want to add that?
Yes, so let me put that up.
Perfect.
So this is the email address here.
So if you want to email Fumiko at that address, she'll be happy to answer anything that didn't get answered tonight. And then the Facebook link for the Connecticut Science Reading Group is also on that page, and we shared that in chat. And to find out when we'll have more series presentations throughout the year that you'd like to attend. But thank you all for coming tonight. And that concludes the evening's presentation.